Good morning, students. In last presentation, we discussed about the concept of moments, Variance theorem, couple, principle of transmissibility, and principle of superposition theorem. Now today we are going to discuss this moment and its numerical. Now first of all, revision of that moment concept. It is nothing but a turning effect produced by a force. Moment of force about any point is product of magnitude of force and the perpendicular distance about that point, and the point about which moment is taken is called moment center. Now here we are going to take the moment of this force about point O. So O is the moment center and D is the perpendicular distance of the force from the point O. Okay, now moment of this force about point O, so moment about O is equal to product of the magnitude of force and perpendicular distance, and this force is rotating anti-clockwise like this. The direction of force is this one, so it is rotating like this, so anti-clockwise rotation, that's why it is plus. Okay, now SI unit of this force is nothing but a Newton meter or kilonewton meter, and the sign conventions, if the force is rotated clockwise, consider it is negative, and if the force is rotated anti-clockwise, consider positive. Okay, now important points to be that noted is that while taking a moment of any force, do not observe the direction of force. Observe the direction of rotation, means clockwise negative, anti-clockwise positive. If any force is passing through the moment center, the moment of that force is 0, because for that perpendicular distance would become 0. Now for example, here if we want to take this force moment about point O, now force is passing through O, so its perpendicular distance is 0. That's why moment of about O, F into D, here D is 0, that's why product of that force into distance 0, that's why that is moment is 0. So keep it in mind while solving the numericals. Now the first numerical, find resultant and its position or location for coplanar parallel force system shown in the figure. Now here that resultant, up to that we discuss or we solve the numerical up to the resultant. Now further we want to find out the position or location of that coplanar parallel force system. Okay, now here four forces are given at point A, B, C, D respectively, and all are parallel to the y-axis, or these forces are parallel to each other. Now we easily can find out the resultant, that is equal to summation of root of summation of x square plus fy square, and here all the forces are parallel to y, that's why the summation fx is equal to 0. No, because no horizontal force is given in the numerical. Now here summation fy is equal to minus 80 plus 40 plus 50 and minus 70. That's why that r is equal to minus 16 Newton. Okay, algebraic sum of this magnitude of all the forces according to the direction. Now minus 60 means nothing but that resultant is acting downward. Okay, now let r intersect at distance x from point A as shown in the figure, and apply to find out the x or position, apply the Variance theorem about the point A. Here that is not given in the numerical, ki find out the position from A point, B point. We considered here for our convenient, consider the A point. So that's why take the Variance theorem about point A. Now this is the x distance, perpendicular distance of resultant from point A, because we are applying the Variance theorem about point A. That's why we are taking the moment or Variance theorem about point A, and x is the perpendicular distance from point A. Now r is rotating like this. Rotation of r about point A is clockwise. So clockwise means minus 60 into x, and remaining force moment Now consider this diagram. So this forces moment about point A. Now first force, this is 80 Newton, is passing through the point A. So its perpendicular distance is 0. That's why moment of this force about point A is 0. Now second force, this at B point, 40 Newton. This force is rotate like this. Like this means anti-clockwise. So plus 40 into perpendicular distance 2 meter. Then next force at point C, 50 Newton. This force is rotate like this. Anti-clockwise rotation. Anti-clockwise. So plus 50 into perpendicular distance from point A. So 2 plus 3, that is 5. Then last force at point D, 70 Newton. It is rotate clockwise like this. Clockwise rotation. Clockwise means minus 70 into perpendicular distance from A point. 2 plus 3 plus 3, that is equal to 8. Now calculate that x distance, that is equal to, by simplifying that, x is equal to 3.83 meter to the right from or of the A point. Okay, so this is the solution of the given numerical. Now next, find the resultant and location. Again, location of this force given in the numerical. Now here one force at point A is horizontal and 3 forces are vertical. Now to find out that resultant force, we need this formula. So root of summation fx square plus fy square. So first find out the summation fx. Summation fx is equal to plus 2. Only one force, that is towards the right side. So and fy is equal to minus 5. All forces are downward. So minus 5 minus 10 minus 15 equal to minus 30 kilonewton. Then put this in the above formula, you will get the resultant. Now resultant direction. Resultant direction, we can find out the direction of resultant by summation fx, summation fy. Now see that summation fx towards the right side or positive and summation fy is negative. So towards downward side. Okay. So x is positive and y is negative. That's why that r lies in the fourth quadrant. Okay. Find out the theta. Then theta is equal to summation fy upon fx. So 30 divided by 20. Theta is equal to 56. Tan inverse of this quantity, you will get the theta 56.31 degree. Now apply the Varignon's theorem about point A. Okay. Here r is in fourth quadrant. Okay. And theta is with x. Why it is with x? Because we take or we find out the theta, tan theta is equal to summation fy upon fx. So जो डिनोमिनेटर में होता है उसके साथ हमेशा थीटा एंगल होता है. So that's why theta is with x axis. Now see, to find out the further that x distance, perpendicular distance, apply the Varignon's theorem about point A. Now by applying first force, that r force, that r is in fourth quadrant. Okay. That's why we consider the r here, and that's why negative sign, clockwise. Okay, it rotates the clockwise direction. Minus 36 point this x, and first force, this 20 kilonewton is passing through the point A. Its moment is 0. Now this force is rotate clockwise. So minus 5 into 2, then minus 10 into 5, 15, minus 15 into that 8 complete distance. So we'll get the x, that is the perpendicular distance of r from point A. Now here r is not a vertical, so it is inclined. So like this, r is inclined, and this is the perpendicular distance of resultant from point A. But we want to find out the d distance, this distance where that resultant cuts on the line AD. Okay, so that's why we are interested to find out the d distance. And here this angle is nothing but a resultant's angle with x-axis or with horizontal axis. That's why this angle is opposite to that of this. So this also having the same 56.31 magnitude. Okay. Now we want to find out this d in this triangle. This is the perpendicular distance. So this triangle AOM is nothing but a right angle triangle. and we have the x distance and we have this angle. So angle means this angle's opposite side we know, and we want to find out the opposite side, hypotenuse of that right angle triangle. So if we want to find out this, and these are the given contents, so here in this triangle we can apply that sine theta. What is this? The sine theta, this theta, this is nothing but the theta. So opposite upon hypotenuse, and we want to find out the d. So that's why simplified according to that, d is equal to x divided by sine theta. So d is equal to this 5.99 from point A. So this is the actually location of the resultant from point A. Okay. Now the next numerical, here a bar ABCDE is subjected to two forces as shown in figure. Find magnitude, direction and point of application of resultant. Means we want to find out the magnitude, direction, and again point of application means nothing but the location of that resultant force. Okay. Now here the find out the resultant. Why we are using that resultant r is equal to root of summation fx square plus fy square? Because here the number of forces are 1, 2, 3, 4, more than 2 forces, and these forces are not concurrent. So apply the second method, that is resultant r is equal to root of summation fx square plus that fy square. That's why we are using that formula. Okay, these are the non-concurrent forces. Now first find out the summation fx of this force. So to find out this x component or y component, we want to find out we have the force and its angle. Okay, so here B force, this force is inclined at B point, C point the force is horizontal, D point force is vertical, and E point inclined force. So we have to find out that the E for 10 Newton force angle with x or y axis, and this B point force its angle with x and y axis. Now observe the diagram. If we observe that this is force is acting at right angle to this beam AE, okay, or bar AE, then if this is 90, this angle is given in the numerical 30. So that's why it is, if we consider this triangle, so this angle is nothing but a 60. So we get this angle of this force 30 Newton force at point B. Now this force at point E, 10 Newton force, this is acting along this bar AE. So if the angle of the bar AE is 30 degree with horizontal, this force is also making the angle 30 degree with horizontal. So we get the angle of this B, this force 30 Newton at B and 10 Newton force at point A. Now apply that summation fx. Now consider this force 10 Newton which is having the angle 30 degree with horizontal, and this is the fourth quadrant force. So x component of this force is towards right side. So 10 cos of 30. Now second force, this 20 Newton force. This is the parallel to the y axis. So x component of this force is 0. Now third force at point C. This force is parallel to the x axis and at point C and towards the negative side. So minus 50. Okay, minus 50. And this force is lie in the first quadrant. So x component is towards right side. So plus 30 cos of 60. Now simplify that, you will get the summation fx is minus 26.34 Newton. That is nothing but towards left side. Now apply the summation fy. Fy again this 10 Newton lies in the fourth quadrant. So y in the downward direction. So minus 10 sine 30. Y component of this force is acting upward side. So plus 20. Y component of this force is 0. And y component of this force is plus 30 sine 60. Now simplifying that, you will get this Fy 40.98 Newton in upward direction. Positive means in upward direction. Now put this two Fx and Fy in our formula. So and simplify it, we get the resultant is equal to 48.715 Newton. That is the magnitude of that resultant force. Now to find out the direction, tan theta is equal to summation fy upon fx. Put that values in this formula. So theta is equal to tan inverse of that quantity, and that is equal to theta is equal to 57.27 degree, and it is in second quadrant. Why it is in second quadrant? Because see, observe the direction of that, or a sign of that summation fx minus and summation fy plus. Minus plus कौन से quadrant में आता है? That is in second quadrant. That's why R is in second quadrant. Okay. Now to find out the position, use Varignon's theorem about point A. Now that R is in second quadrant means like this. R is lies like this. Okay. So R is rotating in minus about this point A. So minus Rx, and moment of all the forces about point A. Now see, one by one we consider that moment of all the forces. Now first at point B, that 30 Newton force, it's directly given in the problem that it is making an angle with that line AB is 90 degree. So 90 degree means this AB is nothing but a perpendicular distance, correct? Now second force, that is 50 Newton force, is horizontal. If the force is horizontal, then vertical is the perpendicular distance. Okay, because this horizontal and vertical line meet at a 90 degree. That's why for this 50 Newton force, Cm is the perpendicular distance. Now see this next force, 20 Newton, is a vertical force. So for this vertical force, this horizontal is the perpendicular distance, An is the horizontal distance. So that is perpendicular distance because force is vertical and this line is horizontal. So meeting at a 90 degree. Okay, vertical and horizontal line. That's why for vertical force, horizontal is the perpendicular distance, An. And last, this inclined force is passing through the point A. We are here considering Varignon's theorem about point A. So this 10 Newton force is passing through this point A. So its perpendicular distance from A is 0. So no need to find out the perpendicular distance for this 10 Newton force because it's 0. Okay. Now see, this force at point B is rotate clockwise about A. So clockwise is minus 30 into AB. This force 50 Newton at point A कैसे rotate हो रहा है? Like this, anti-clockwise. So plus 50 into Cm. Now this force, 20 Newton force at point D, it is rotate clockwise rotation. So minus 20 into An, and this 10 Newtons, because the perpendicular distance is becomes 0, that's why moment is 0. Now put the value of AB, Cm and An. Now AB is nothing but a 2 meter. Then this Cm, vertical distance. So consider this triangle. Okay, AMC, complete triangle. It is a right angle triangle and this angle is 30 degree. Okay, and we hypotenuse is 2.5 plus 2. That means 4.5 meter, and we want to find out the Cm, means angles opposite side. So if we have the right angle triangle and we want to find out the opposite sign, so apply the h sin theta. H sin theta means h is the hypotenuse, and sine, apply the sine and simplified it, you will get that opposite side Cm is equal to h sin theta. So that h is nothing but 4.5. So for this force 50 Newton, Cm is nothing but a 4.5 sine 30. Correct. Now this next force, 20 Newton force, that An is the perpendicular distance. Now consider this big triangle, this AND, this triangle. Here hypotenuse is 3 plus 2.5 plus 2, and we want to find out the theta's adjacent side. An is a theta's adjacent side, and in the right angle triangle, if we want to find out the theta's adjacent side, apply the cos, simplified it, you will get h cos theta. An is equal to h cos theta. So that's why h cos means here h is 7.5 cos of 30 degree. Okay, now simplified it, put the value of r, you will get the value of x here. That is perpendicular distance of resultant from point A. Okay, so summary, we discussed now moments Okay, revise that moment concept again, and its numerical, different types of numericals. Okay, thank you.